to the second part of the mock paper 2025. This is part 2 of the question number 3b, part B, second part. Astronaut, we were doing this, chosen to go on a mission. Each of these astronauts are taking place 3 personal positions. So here it's very much clear that each of these astronauts are taking 3 personal positions. So 4 astronauts are there, 4 times 3 each. We get 12 total positions. So we have to find how many different ways that 12 positions be arranged in row if each astronaut's positions are kept together. Yani 1, 2, 3, 4 astronauts. Each has any A1, A2, A3, A4. If each has positions together, so here we have different options. Out of the 12, there are 1, 2, total 12. So we can say we need to consider, first thing we need to consider astronauts as a single unit. This is all astronauts together out of 12 as a single unit. Then the number of ways they can be arranged will equal to any, these are A1, A2, A3, A4. They can arrange in 4 different ways. So it goes to be 4 into 3 into 2 into 1. That goes to be 6 to 4 are 24. 24 ways we can arrange the astronauts. Now we have to arrange their positions. Now, because written if each astronaut's positions are kept together. Now arrange positions within each. Within each mean with this we have positions, with this we have positions, 3 positions. Any 3 factorial here, 3 factorial here, 3 factorial here, 3 factorial here. In 3 positions for any order with each astronauts, right? Within each astronauts group. Then it can be range as we can say that is 3 factorial. It can be come in any order. So therefore total number of ways is 2 marks question. So these wordings help you to understand what is going to be asked and what we have to find. And here total possible ways for the order selection, that is 4 factorial. 4 astronauts can become in different orders, and 3 factorial with the 4 persons. In 3 times 3 times it comes to 3 for each. So instead of writing 3 into 3, or you can write it as 3 factorial times 3 factorial times 3 factorial times 3 factorial for 4 astronauts. So this can be written as 4 factorial times 3 factorial whole power 4. So with the help of calculator we can get it. Okay, yes, 4 factorial times 1296, yeah, 31104. I get this one. You can check your result with your calculation. Okay, now go for the next question. Question number 4. It is said in a certain country the probability of more than 10 centimeter of rain on a particular day is 0.18. It means if x represent a rain and rain is more than 10 centimeter, the probability is given to be of this is 0.18. So this is a value of P. We can say this is P, probability of rain more than 10 centimeter, and it is less than more than 10 centimeter. You know 1 minus 0.18, it can be 0.82, we can get it. So okay, find the probability that in a randomly chosen 7 days period, okay, n is 7, more than 2 days have more than 10 centimeter rain. It means what probability of x is greater than 2 days has probability bigger than this one. Okay, so this can be calculated as 1 minus probability of x is 0 plus probability of x is 1. You can calculate it to get the answer. Okay, more than 2 days. So more than 2 days, one more thing, it can equal to be 2 as well, right? So this is case study of the x belongs to a binomial distribution with n is 7 and p is 0.18. You can use it. 1 minus, here I'm going to solve 7c0 and 0.18 power 0 and 0.82 power 7 plus 7c1 0.18 power 1, 0.82 power becomes 6 plus 7c2 0.18 power 2, 0.82 power 5. So now use the calculator to find your result. We will see 1 minus this comes to be 0, approximately 0.23, with 1 it will be approximately 0.506, and with 2 it will be 0.332. So all about, and finally once you minus it, 1 minus 0.861, and it gives us the final answer as 0.139. That is the answer for 3 marks. I hope it is clear. It's a simple question based on the binomial distribution. Let's go to next. Okay, it's given three randomly chosen 7 days period. Find the probability, be part of the same question. The same goes for this. Now probability that exactly 2 of these periods have at least 1 day for the 3 randomly chosen days, more than 10 centimeters, at least 1 day. So probability of x is if its range is greater than or equal to 1. 1 day it is this. So n is what here? 3. P we know that for that was how many? Exactly 2 of these periods. Period was 7 days. So P is 2 by 7. And what comes Q? 1 minus P. 5 by 7 is 3 marks question only. So X is belongs to a binomial with 3 and 2 by 7 and P. So probability of X is greater than or equal to 1. Mean 1 minus probability of X equal to 0. It will be this. 1 minus n is 3, 3c 0, P power 0 and Q power 3. We will calculate it to get the answer. Let's see what. With calculator we get 1 minus 0.3645, 0.6355. That seems to be the answer of this question number 4. Now go for the next question. Question number 5. Ili has 4 sided dice with the side label 1, 2, 3, 4. He throws for all 4 dice at the same time. The random variable x denotes the number of twos obtained. So fine. So it means probability of we have to show that probability x is 2, 3 is 3 by 4. So probability of 2, that will be out of these 4 numbers. We can say it's 1 out of 4, and probability of not getting 2, probability of not getting to 1 minus 1 by 4, that will be 3 by 4. Very much clear. And this is simple case study for the discrete distribution. So out of four-sided dice, so we can have, if x is denoted by say k number, 4ck p power k q power 4 minus k. Okay, now we have to take k3 for 3 4c3. P is 1 by 4 of 3. Q is 3 by 4 power 1. So 4 3 is 4, and this is 1 over 164, and it's 3 by 4. 4 cancels. So probability of x equal to 3 comes to be 3 by 64. It was so easy. 2 marks question. And now complete the following probability distribution of x. Yes. So instead of writing this, I can write like this. It's 0, 1, 2, 3, 4. And we have to find a probability of x is small x. Few are given to us. We know this ncx, or you can write ncx, x or k, right? P power x, q power n minus x. This is the binomial distribution. K simple is this. When x is 0, it is given us 81 by 256. No need to work on it. But n is 1. X is 1. So 4c1 p is what? 1 by 4 power 1, and q is 3 by 4 power 3. I will get it. Okay, 108 by 256. So similarly, 4c2 1 by 4 power 2, 3 by 4 power 2 as well. So it will be calculated as same as 108 by 256, or you can simplify it as 27 by 64. Okay, and rest are given to you. That is given 3 by 64 and 1 by 256. We know the sum of the all, it should be 1, or sum of the all probability distribution should be 1. We can check our answers, and here it is, this is same, this will be same, this is same, and if I multiply this with 4, it will be equivalent to 12 by 256, and this is 1 by, so we will calculate it. It will be 256 by 256, that goes to 1. Yes, true. So this is the 2 marks table completion. And next one is 1 marks expectation of x. That is mean of x. We know that in binomial, because it seemed to be a binomial discrete case. So in binomial distribution, no need to go with the, by using this formula for x into p of x. And although it will take little calculation, but answer will remain same. But here we can say, because x is a binomial distribution, so its mean is x n p. N is what? Here n is we have 4, and p is as well 4 by 4. So expectation of x is 1. This is the answer. Simple case. Proceed to question number 6. And important one, a factory produces chocolate in 3 flavors. 3 flavors are lemon, oranges, and strawberry. In the ratio are 3. Okay, let me, that is orange ratio, lemon ratio orange, ratio strawberry. That is 3 ratio 5 ratio 7. So total is 15. 1 marks question is this. He said, Neil checked the chocolate on the production line by choosing chocolates randomly one at a time. Find the probability that the first chocolate with lemon flavor that Neil choose is the 7th chocolates that he checks. She checks. So 1, 2, 3, 4, 5, 6, 7. If she succeeded here, so it means here for before 7 is first 6 attempts she got failed to get the lemon. So I say this is the special case of geometric distribution, that is probability P. So probability of lemon is 3 out of 15. That means 1 by 5. If this is P, so the Q will be 4 by 5, not getting lemon chocolate. So in the sixth attempt, it means if he succeeded in seventh attempt, so first 6 has been failed and 7 she won. So replace the value here. It's 4 by 5 power 6 and 1 by 5. We'll simplify to get the answer. A big answer on the calculator: 4096 divided by 78125. I got this one. Either you can write in decimals, choice is yours. Okay, fine. Second case of 2 marks again. This was the first 1 marks question, so easy. Find the probability that the first chocolate will with lemon flavor, lemon nail chocolate, is after she has checked at least 6 chocolates. It means probability of x is greater than equal to 6. Mean 1 minus probability of x is less than equal to 5. It means first 5 attempts she lost it, and it should be minus from 1 to get that is at least 6 onward she get the required flavor. So this is 2 marks, needs some little calculation. So we can say it's 1 minus here probability of x when it is not from 0, 0, not no such. So it means 1 starting from 1 plus probability of x is equal to 2, x equal to 3 plus probability of x equal to 4, and final probability of x equal to 5. We will find all these probabilities by geometric progressions, and x belongs to geometric with probability p. P is what? 1 by 5. So you can use this. So probability of x is greater than or equal to 6 will be 1 minus this all. Okay, I can say if she won first, so it means nothing to be lose, plus in second attempt x is 2, so it means once she failed, if 3, 2 times she failed, 4, 3 times she failed, and 5 she failed 4 times, and 50 she won it. Now just replace the value of p and q here, and you can calculate it. 1 minus okay, p is 1 by 5, q is nothing, so no need to write 1, plus 1 by 5 is 4 by 5, 1 by 5, 4 by 5 square, plus 1 by 5, 4 by 5 cube, plus 1 by 5, 5, 4. We can use the calculator, and you will see the final answer will be yes, 1024 over 3125. This will be the final answer. Okay, one more part to go. C and D, there are 2 more parts to go for this question. It's a little lengthy question. Surprise books of chocolates each contain, here what to say, 15 chocolates, 3 lemon, 5 the same one. Peter has a box of surprise chocolates. She chooses 3 chocolates at a random from the box. She eats each chocolate before choosing the next one. It means this is a different case study. This is a case study of that without replacing. Once she eat it, the total number will be less than. And then she eat, and then she will go for the next selection. Then she finish, then she will go for the next selection. It means number of chocolate will decrease 1 by 1. Find the probability that none of the Peter's chocolate has orange flavor. And there are total oranges we have. There were 5 out of 15. Probability of orange if you go with this. Yeah. But this is case study of without replacement. So no, we don't go with this. Without replacement. There were total pattern any you can say there are given 3 are lemon, orange and strawberry. There's 5 and 7, total is 15. Okay. Find the probability that none of the Peter's chocolate has orange flavor. If you can see, if none of the sorry, here let me check the select the color. If this color is not coming up, so rest of 3 plus 7, 10 colors, out of 10 color any can become. So probability of uh, no orange flavor out of 3 attempts, so it means out of 10 we 10 can anyone can select it for, either it can be lemon or strawberry. It out of 15, and next after eating this there will be 14 left again and 9 other colors. Again there will be 8 out of 13 because these are other colors, lemon or sandwich, not the oranges. Out of 10 it can be 10 out of 15, then 9 out of 14, then 8 by 13. We can simplify this on a calculator to get 24 by 91. Check it out. 2 marks question. D says the final probability that each of the Peter's chocolate has a different flavor. It means if out of lemon 5 and strawberry 7, total 15. It means all 3 colors comes up. But as the case study is without replacement, because said she finished one and then eat one and then switch to next, like the next one. So first say that is you can say is if lemon comes different color lemon out of 15, and then strawberry out of 14, and then 7 out of 13. So we can say 15 7 105 out of, and you multiply these things, already we have done 2730 or 182 is this is the answer. I hope it's clear. Yeah. And the final question. The height of a book in a library is centimeter, have normal distribution. It's given as a normal distribution. X belongs to a normal distribution with the mean is 21.7 and standard deviation in this variance is this. A book of height of more than 27, it means if probability of X is greater than 29 is considered as large. If height is no probability X height is more than 27 is considered as large. So this distribution, find the probability that 8 books chosen at random. Probability if n is 8 chosen books at random. A book is a height of more than 29. Book height of more than 29 is classified as large. Okay, good question. Because here we don't have what's going to be P and what's the next. Find the probability 8 books chosen at random. N is what? 8. And the probability of X is less than 2 are classified as large. So as large. Okay, we have to find the probability of this. So first thing we need to find the probability. If probability of X is greater than 29 is equal to probability of large. As X is normally distributed, so standardized variable X minus mu over sigma. Let's see what comes P here. And we'll substitute it 29 minus 21.7 over 6.5, we will calculate it and we will get 1.123. Therefore it implies probability of x is greater than 29. That's supposed to be large. Oh, sorry, my pen broke. Okay, the probability of x is greater than z will change. The probability of z is greater than 1.123, and if you can draw the shape, it's bell shaped symmetrical distribution, we will be here. It is 1 point, if 1.13, sorry, 1.123, we, we need to get the greater value. So this comes to be probability of z greater than 1.123 mean 1 minus probability of z is less than 1.123. As per rule, from the z table, we will see 1.1 in 2 and add the difference of 3. Okay, let me repeat it. You will see 1.1 in 2 and then add the difference of 3. We will get it as 0.868, and after minus it from 1 we get 0.132. That is the probability of z standardized variable 1.123. That's this answer. This comes to be the p here. Now as n is 8 and we have to find x is less than 2, less than 2. Okay, and that means two books are classified as large. Okay, so it means this goes to be the binomial distribution now, with n is 8 and p is what? P comes to be 0.132, right, for large. So that is probability of x is less than 2 mean, that is probability of, okay, we can see probability of 8c2 and 0.132, no, not 2, it's 0. It can, because less than 2 it can be 0. I can write it as probability of x is 0 or probability of x is 1. That means it's less than this one. So we can write 8c0, p is 0.132 power 0. Q will be, if p is 0.132, 1 minus p, we will get 0.868. 0.868 power 8 plus 8c1, 1 to 2 power 1, and 0.868 power 7. Calculate it and we'll get the answer 0.903. That is the final answer. I hope you got it. This is a 6 marks question. So this is the final topic, and there is one more part. Somehow it's not here. Let me write. It is, oh, okay guys, I have written the question here. N books are chosen at random. The probability of there being at least one large book is more than 0.98. So it means you are given probability of x is greater than or equal to 1. At least one large book is 0.98. Now you are given the probability and you have to find the number. This is 3 marks question. Okay, and same case, we have to find n, the least possible, means smallest value of n we have to find when this. So from the table, probability of x is greater than or equal to 1 mean it will be 1 minus probability of x equal to 0, right? We can do this. So 1 minus probability of x 0 mean it is probability of x. It means p power 0 q power will be uh, any out of this one is n. We don't know what is n, so n, let n be n. So, and this is given to be 0.98, right? We'll do it laterally. Let it be this. This has 1 minus p was what? We know probability of one large book was, we already calculated 0.132 in the first part. So q will be 0.868. This we have done from part A, from A part or the first part. So we can say 0.868 power n, and that is given, and that is it's given that it's greater than, at least is greater than or equal to 1. So we can say this is what 1 minus 0 point, I'm just substituting the value here. This answer was probability of x is greater than or equal to 1. We know this. Now I'm substituting this value over there. So 1 minus 8.868 power n, and it will be greater than 0.98. Here it is greater than, we are looking for greater, and is more than, it's said more than, so I put it greater, not equal to. So simplify this, we get 0.868 power n, and simplification will be 0.02. So in order to find n, take log on either side, log or base l, and natural log, it doesn't affect it. So n less than log 0.02. Simplify this, apply the property, and becomes before 0.868 less than log of 0.02. So n, its value will be calculated as minus 0.0617, and its value is minus 1.698. So when you divide it, it becomes greater, 1.698 or minus 0.0617, minus goes with minus. So calculator will give us the value, it will be 27.5. So n is numbers greater than this will be 28. So n is 28 is the right answer. There are different approaches as well, but I find this is not difficult one, because the log method, you know well, in pure mathematics 3 you have done the logarithm chapter. Okay, good luck. We will come for the next paper video. As soon as you will get the paper, inshallah I will upload the results. Good luck, guys.